In this video, I am going to talk about reverberation, reverberation time, absorption coefficient and how to determine the absorption coefficient of a material. Firstly, let us discuss what is reverberation. Generally, when a sound is produced in a medium, it falls on all the object in the medium. For example, if a sound is produced in a room, it gets reflected from the wall, it gets reflected from the object present in the particular room. Okay. So, we get reflections of the sound reflected from various objects. So, the sound produced at one place in a building falls on the walls, ceilings, floors, fans and gets reflected. So, apart from hearing the direct sound, the listener will also hear the sound from the reflection. So, we will keep on hearing the sound or the reflected sound, and there is a phenomenon of this reflection of sound even though the source has stopped producing the sound. Okay. So, the persistence of the sound due to repeated reflection even after the source has stopped to emit the sound is called as reverberation. And what is the reverberation time? The reverberation time is defined as the time taken for the sound energy or the sound emitted by the source or the intensity of the sound to fall from its initial value to its 10 power minus 6 times of its initial value. Okay. So, the time delay or the time taken for the sound energy, the initial sound energy to fall to its 10 power minus 6 times its initial value is called as the reverberation time. If you take I naught or E naught to be the intensity of the initial sound and I is the intensity of the sound after time t, then we can define the reverberation time as I is equal to, the condition for the reverberation time I is equal to 10 power minus 6 times I naught. So, the intensity of the sound to fall from I naught to 10 power minus 6 times I naught is called as reverberation time. Then absorption coefficient. So, when I produce a sound in a room or a building, it falls on all the materials. So, those materials have the capability to absorb certain material. So, each and every material there will have an absorption coefficient. So, the absorption coefficient is defined as the ratio of sound energy absorbed by a body to the energy received by the body. So, it is equivalent to the ratio of sound energy absorbed by a particular substance to the total energy falling over the body. So, this we call it as an absorption coefficient. To honor Sabine, who gave a formula for reverberation time, the absorption coefficient is measured in terms of the unit called Sabine. Now, let us determine the absorption coefficient of a material. So, let us have a hall or a building and excite that building with some sound, and without any absorbing material, the reverberation time is found out and it is determined to be T1. And let us say A to be the absorption coefficient of the hall and S is the surface area of the hall. Then the total energy absorbed in the hall, that is A into S. Now, let us from Sabine's reverberation formula, we know T is equal to 0.161 V by AS, and the reverberation time for the building without any absorbing material, it is T1 is equal to 0.161 V divided by AS, where V is the volume of the hall and A the absorption coefficient of the hall and S is the surface area of the hall. Now, let us fill the hall with the absorption material for which we wanted to find the absorption coefficient. and then let us excite the sound again, then find out the reverberation time, which we notate as T2. Here A prime is the absorption coefficient of the material, for which we are going to find the absorption coefficient, and S prime is the surface area of the material. Then we have T2 is equal to 0.161 V divided by AS, that is the absorption coefficient or the energy of the hall, plus the absorption coefficient, A prime into S prime, that is the energy of the absorbing material. So, from 1 and 2 we can write 1 by T1 is equal to AS divided by 0.161 V, and 1 by T2 AS plus A prime S prime divided by 0.161 V. So, let us subtract 4 from 3, 3 from 4. So, 1 by T2 minus 1 by T1, you get A prime S prime divided by 0.161. So, in both the terms you will have AS, they get cancelled. So, A prime can be found easily as 0.161 times V divided by S prime into 1 by T2 minus 1 by T1. So, using this expression we can easily find the absorption coefficient of any material, any body.